Hello and welcome to the build video of the MU-ltiple, the super simple passive multiple. And I don't think you will find a kit that is more easy to solder than this. This is what you get if you buy it with all the parts, and it's 12 jacks, breaking jacks. If you choose to source them from somewhere else, that is the important thing. It works with Donkey Kong jacks, which I believe are breaking jacks as well. And the only thing you have to think about is that the ground lug here, you need to bend a bit to get it aligned with the hole on the board. So you do that, and then you need, if you have made something else and have a few spare legs from components that you've used, or just some wire to connect the ground to the PCB, ground lug to the PCB. Technically you just need to do this with one of these lugs, because as you can see, all the jacks are connected with this little design feature, but also a ground connection between everything. But I'm going to choose to connect them all together. There's also another thing when it comes to ground, that is that on this side, to save space, the two jacks on the right side actually share ground. So first one you just bend like so it fits just like the first one. But the second one, you need to take a piece, some kind of tool, and bend it like upwards, like so. So you then can connect it like so, and then trying to align these two so they align along with the PCB. So that's a bit tricky, but there needs to be something tricky, so you have a challenge, I guess. So let's just try to get all these in. And it's just a matter of adding them one by one. Let's see if I find something to put under here. Yeah. And these, I do that extra bend, oops, on the ones on the left, or half the ones on the left. And last one. So. Now, before we solder anything, we need to add the front panel like so. So we know that it all lines up. if we solder it in place and it doesn't line up, you're gonna have a problem afterwards trying to fix it all. Oops, sorry about that. So, and then we just solder all these together. I'm going to turn on the fan because fumes. And when you solder, make sure you get good adhesive to both the pad on the PCB and the lug. So I usually go in at a 45-degree angle, so you get connection to both of them. So you see that the solder melts together with the two, and you get a nice like a mountain tip. There shouldn't be a dip down or like a volcano crater. That's wrong, and it should be like a tip and not like a crater. So, with some geology anecdotes. Right, so this one actually has one of those craters, kind of, so we just add a bit extra and we see how the solder just moves up the leg, and then we know that one is good as well. So now it is soldered and we need to add ground before we are done. So I'm just gonna strip this cable. And yeah, which way to do this, I don't know. Either you do it like this with the panel in and you attach the leg from this side, making sure you hit all the holes and start soldering from this side, or as I saw someone do, you do it from this side and you just connect it like so, and you start from soldering from this side. Either way is good. And if you use component legs, you won't have this problem with a really long piece of wire that I have now. And these that are dual could be a bit difficult. Just make sure you get them in there both, and that it sticks out a bit at the bottom. And then we need to get in here with the soldering iron. And it's difficult because you don't want to mess up the plastic on the jacks as well. And again, I want to point out, if you're feeling lazy, then just connect these on the back, and once you connect it here with the nuts, then technically you should have ground on all the jacks. But I'm going to do it the hard way and connect all of these, or solder all of these. It doesn't take that long, usually. I would say that is one of the most positive things with printed circuit boards instead of protoboards and just one-off panels. That is that the panel components is always the components that take the longest time to assemble and to get in place as they should be. And that is definitely the good thing with printed PCBs. Even though I do make it a bit more difficult with this design, I know. There. Making sure they're both connected. And this one. Gonna bend the legs a bit. See if we can. Yes. And the final one. Which, according to Murphy's Law, needs to be the hardest one. Yes, come on. And final one. not connect to the lower one, so we need to add a bit more. Solder like so. And now they are connected. And of course, solder them to the PCB. There. And then we connect the front panel. If you want, you can remove the lugs with a snippet tool. I choose not to do it. They should not pick up too much interference. And this is one tedious part of this now, that we need to add 12 of these nuts. Two left. Right, so always good to tighten these a bit. When you do this, make sure you don't scratch the panel too much, if you don't mind that, of course, but I'm always a bit angry when I do my first scratch on a front panel, just because I'm not careful enough when tightening a nut or something. So here, we are done. 20 minutes of soldering and talking. We can do some simple tests. We can just, with a continuity tester, just make sure that all the ground is connected, which they are. We can, so we have the input up here. That one is the input, should be connected to both inputs, that one and to the pin, this one of the next pin, and also of course to every other pin, because it is not connected to anything, and all the braking jacks are connected together, so all these lugs on the back should actually be plugged together, and we break the jack. So how this works is we have an input signal that is, when only an input signal here, it is multiplied to all these outputs. But once we connect a cable here, it is broken up here, so this one becomes a 1-2 instead of a 1-8, and this one becomes a 1-6 until you plug something in here, for example. Then you have a 1-4 and a 1-2. So 1-2, 1-4, 1-6. So you break them by adding stuff here, but if you don't add something here, then it will just continue to multiply or add along the line. So here we have the simplest of tests. We have a VCO into first input, and on the first output we hear that we have a signal, and this signal is multiplied all the way down. So we have a 1-8 multiplier here. But if we add another VCO to this one, then we break this line, so up here we still have a 1-2 multiplier on this signal, but down here we now have a 1-6 from this, and of course if we do like this we have a 1-4, and up here we have a 1-4, and that's the beauty of this multiplier, that it can either be 4 individual 1-2, or 2 individual 1-4, or 1 individual 1-2 and 1 individual 1-6, or 2 individual 1-2 and 1 individual 1-4, just as you'd like. So very versatile in that sense. So hope you understood that, and if you want to buy this or build it your own, here is the DIY version that you can go through in my Modular in a Week series, where I build this on day 3, I believe. I build passive multiples and many other things. So thank you for watching. Bye.